So what's up, YouTube? My name is Jonathan Vaughn. My friends call me John. You can call me John. You don't have to call me anything since you are on YouTube and you're just watching this and you'll probably never meet me. But I did upload a video of my robot. Here's the code for it. Let's walk through the code for it really quick. It's pretty simple. So I'm using the new ping library. With the new ping library, I'm able to declare some new ping objects. I've got a right sonar and left sonar. And why do I have these? I'll show you why I have these. Because I have a right sonar and a left sonar on my robot. Alright, I promised you I would put some video up of my robot, so here it goes. I also have these two integers, one for the right distance, one for the left distance. I have these, one for the right count, one for the left count. Start serial, these pins control my motors, set the distance to 0. So basically the first thing I do in my loop is I get the distance. As long as the right and left distance are greater than 40 centimeters, then I'm going to set right count to 0 and left count to 0, and I'm going to go ahead and what am I going to do? I'm going to go forward, and after I go forward I'm going to get the distance so that I can keep updating distance and I can keep going through this loop, and that means I'll keep moving until I have reached an object within 40 centimeters of me. How long is 40 centimeters? Well, that's 40 centimeters right there. I don't know if you can see that, but that's 40 centimeters right there. Alright? So, then once I get out of that loop, I'm going to brake so my guy will stop. And then what I'm going to do is I'm going to check to see if the right count and the left count are both over 5. If they're both over 5, that means that my robot has been sitting somewhere going back and forth just like that for no reason, which basically means he's stuck in a corner. So if I go like that 5 times on each side, then I'm going to go backwards and I'm going to turn to whatever side that has a less count. So if I go this way 6 times and that way 5 times, then I'm going to go backwards and I'm going to go that way. All right. Then I'm gonna brake after I go backwards and I'm going to turn. And then I'm going to set my count back to 0. If my right count and my left count aren't both over than 5, then that means I'm not sitting in a corner somewhere. That just means I've seen an object, and that allows me just to rotate to get that object out of my way. Okay, so that's pretty much all I do in my loop. There's my brake function, forward function, backward function, turn right, turn left function. There's my function to get distance, okay? So the videos I uploaded on Facebook, so let's see. Make sure my volume's turned up so you can hear it. Yep, that's turned up. That's turned up, so here you go.
Alright, so I did make a couple changes.
Cool little maze I'm going to make and go through.
I made a good change where
if you're my Facebook friend, you can find these videos and you can
my nameless robot to get out of a corner whenever he gets stuck in one. But he should be able to at least go through this little tiny maze right here. And hopefully, I'm not lying whenever I say that. He should be able to do that. And he's doing good so far. He's a good little robot. He's a good little dude. And he's went right through the cups. Oh, he hit a cup. I'm not very happy about that, but such is life. Alright. So there's that. Which I'm pretty proud of him there. He did a good job there. Now the issue is let's see what he does whenever he gets over there. That's the real issue.
So now he's in a corner.
There he goes.
Now look right here and I'll show you what's going on. So you see how he's rocking back and forth there? Well, that's what this code up here does that I showed you. This code up here that checks if right count and left count are both greater than 5. It checks exactly for that rocking distance. So if he's rocking back and forth like that because he's in a corner and doesn't know where to go because he's in a corner, and the right distance and the left distance are relatively equal, or every time he moves they switch back and forth, so the right distance is greater, so he goes to the right, and once he goes to the right, now the left distance is greater, so he goes to the left. When he does that, right becomes greater, and he just keeps going back and forth. That little part of code right there keeps him from being stuck there forever and allows him to go backwards like he just did.
There he goes. There you go, buddy. Not stuck in no corners no more, are you? Alright, let's put him in another corner and see how he does in a big corner.
He doesn't do so hot in big corners there.
Tell you what, he's not happy about it, I know that. So big corners kind of a problem. Little corners not so bad, but these big ones, I'm gonna have to figure out some type of different algorithm for these big ones, because he is not a fan of the big corners. He has some serious issues whenever he gets to the big corners. So he really just wanted to flip over, didn't he?
Let's go ahead and get out of there.
At least he finally got out of there. Let's take him and run him through this maze one more time. Alright. Let's put him in this maze one more time. What he's doing, I'm pretty proud of him with how he's doing in the maze. He is doing pretty good in the maze so far. Come on, for being a two-day-old robot, he's pretty smart whenever it comes to mazes. He's pretty smart whenever it comes to cuts. Now corners, he's not really doing well on corners, which I already explained to you why he's not doing good on corners. It has to do with how he sees. He sees kind of like a bat. He uses an ultrasonic sound frequency, so a very low hertz frequency that you and I can't hear. I guess he didn't want to be in the maze anymore. Is all I can think of there. He just decided he didn't want to be in the maze. So basically, let me show you what's going on here. Okay. So here's his eyes. Right. One's a transmitter, one's a receiver. One of them transmits a very low frequency sound. The other one receives a very low frequency sound, or high frequency, one of the two, I can't remember. So basically, here's what happens. Sends out a sound from here. Sound waves hits the wall, bounces back. Calculate the speed of sound, because I measure from the time it takes me from whenever I send it out to the time it takes me to receive it. And I use the speed of sound, divide that in half, and I'm able to calculate how far away that object is to a very accurate distance, within plus or minus 3 centimeters is my tolerance. So very, very accurate for this guy. Now his issue is here, okay? So basically, at this angle, he's approaching the wall at pretty much a 30-degree angle.
So here's the basic problem right here, which I'll show you. Alright? So, sound usually comes from here and hits, and if this was perpendicular, alright, then the sound would hit here and it would bounce back and go in there, and he would be able to measure something. But the issue that he has is this is not actually perpendicular. This wall actually goes down like that, just like you can see. So what happens is sound hits here and it leaves at a complementary angle here. Okay? And the greater that this the greater, let's do it up here. Okay? So if I come in at this angle and blast with my sound's gonna bump out this way. So the only way that I can see that object is if I'm somehow perpendicular to it, okay, and I'm perpendicular to this wall, and I bounce sound off there, because then it can come back perpendicular and get me. This is the issue that I'm having here, okay?
Here. Okay, so what will happen is he'll shoot out a sound here, but instead of coming back, the sound actually
That's what I just explained right there.
Not actually going to just come hit the wall and go straight back to him. It's going to hit this wall at this angle and leave at the complementary angle. So it never comes back to the receiver. So hence, whenever he gets here, he doesn't really understand that there's a wall there, because he can't see it. And yeah, sure, that's pretty cool that he wants to climb it and everything, but not really that cool. I don't really like it because he'll flip over and give himself black eyes. So that's one of his issues, which I'm going to fix that by incorporating some infrared sensors. And those infrared sensors, I'm going to send them through the maze one more time because I really like him doing that, and that's really cool, I think. So I'm going to get some infrared sensors. Those infrared sensors are going to be for close proximity like that. So whenever he's in a close proximity, one cool thing with light is it doesn't just bounce in one direction. It doesn't hit and then go off in a direction. It actually hits and spreads out and goes everywhere. So with an infrared sensor, it doesn't matter what your angle of approach is, you're always going to get some infrared back as long as you're in a certain tolerance. And I'm going to set his tolerance to about 10 centimeters, 15 centimeters. He's out of the maze. Pretty good job there, buddy. I'm going to set his tolerance 10 centimeters. And if he gets within 10 centimeters of something and sees it on his IR, then he's going to be able to go ahead and turn and adjust right there. So he will, in theory, never actually hit a wall and never be in that issue. Then, once I come up with a better way for him to figure out how to actually get out of a corner whenever he gets in a corner, and then I need to figure out a way for him to actually localize and know at all times where he.
Localization is just for the robot to know where he's at on an XY plane, or if you're doing something three-dimensional, for the robot to know at any given time where he's at on an XYZ plane relative to his starting position.
Actually is, so that he can figure out, hey, where am I at, so he can work on building the map. So,
localization is very important in map building robots, because if your robot doesn't know where he is, if he's not consciously aware of where he or she is on an XY or XYZ coordinate system, then whenever he does a scan and he gets more information for his map, he has no real way to know where that information goes relative to his last scan. So in order for a map to be built, the robot's going to take a scan of the environment and put it on a map. Well, then he's going to move and take a new scan of the environment. Well, in order for that map to make any sense, he needs to know his relative position based on his last position so he can fuse that new data into the map. If not, your map is not going to be an accurate map of your environment, and it's not going to make any sense whatsoever. Localization is a very hard problem for robotics. It's one of the biggest things I've struggled with here. What I'm doing right now is called dead reckoning localization. I'm using 2 compasses and some type of filter to reduce the noise in those compasses, and I'm using the encoders built into his motor to get a linear vector, and then use the linear vector and the orientation bearing and some trig functions to calculate an XY position. It's not very accurate because every step that you have some type, like for example, the compass has one has a plus or minus 2 degree error rate, the other one has a plus or minus 5 degree error rate. So you could say that we're going to have, let's say, a plus or minus 3 error rate between the 2 compasses. So every step, if I'm off 3 degrees one step and off 3 degrees the next step, as time goes on, it begins to compound, and my real location based on my computed location is very inaccurate. So dead reckoning becomes an issue over time because of noise and your sensors, and that's something I have to deal with. Not quite sure how I'm going to deal with that yet.
Since I gave him the knowledge and taught him how to reverse, then he actually kind of doesn't ever get through this maze on the backside like he used to going. Where there's a farther distance. Is there a farther distance on the right? Well, and he'll clear that, okay? But whenever he gets into this situation here, relatively, he's looking, things are basically at the same height. So he'll go that way, and then now he'll look, and there's more distance in between here than there is here, so he'll go that way, and then it changes, and he'll go back and forth and just keep rocking back and forth. So I set that if he rocks back and forth like that, let's say 5 times, well, then you're stuck somewhere because all you're doing is going back and forth, that you need to back up and try again. So that's not a very smart algorithm, and it doesn't work very well, so I can tell. But I guess the even bigger question is, does anyone smell honey mustard? This is the next thing that I'm doing right here. This is a multiplexer, it's a 3x8 multiplexer, thanks to Dr. Doyle for giving me some information about those, so I can make some really cool stuff like LED cubes. Anyways, there you go. I just wanted to let you know that he does know how to back up now, so that's it. Plus, I'm putting these on Facebook and YouTube.
So that's it, YouTube. If you do want to watch more videos of the robot that I don't put on YouTube, because I only put them on Facebook, you can always go to this link right here, facebook.com/king.john.vaughn, and you can hit the little button that says add friend. I will accept you. I won't say, hey, weirdo, I'm not going to accept you. I will accept anybody because I don't really care. I don't really discriminate. I don't care where you're from. I'll be your friend. So if you want to watch some more of these videos or just know anything about what I do on Facebook, which is some pretty interesting stuff, feel free to add me. If not, if you want to see more information about the robots that I build, or if there's any particular tutorial that you'd like me to build, like how to program for Arduino or on a Raspberry Pi, or how to program in C or Java or F#, or make Android apps, or how to reset your Android, or how to fix your computer, or anything that has to do with technology, like how to build a neural biofeedback device and begin to get biofeedback from your brain so that you can control your robot with your brain functions. Any of that stuff, I'd be happy to do it. Just leave a comment or send me a message or add me on Facebook. Whatever. That's pretty much it for this. Thanks for nothing.